Let's go ahead and trace this Fibonacci function using a tree. So on line 20 in main calls Fibonacci function with an argument of 5. And again, I'm going to use F to abbreviate Fibonacci. The compiler enters the function on line 28, and on line 31 it checks, is 5 equal to 0 or equal to 1? The answer is no, so the compiler jumps to line 37. And on line 37, the first Fibonacci recursion function is called with data minus 2. So 5 minus 2 will give us 3. And again, the compiler enters line 28. The compiler then jumps to line 31 and checks, is 3 equal to 0 or 1? The answer is no, so the compiler jumps to line 37. And on line 37, f of 3 calls its first recursive function Fibonacci 3 minus 2, which is 1. So f of 1 is called. The compiler jumps to line 28 and it enters the Fibonacci function. On line 31 it checks, is 1 equal to 0 or 1 equal to 1? The answer is yes, and so it returns data. So f of 1 will equal, it returns 1. The control then goes back to f of 3, and f of 3 resumes on line 37. And on line 37, f of 3 calls its second Fibonacci recursive call, and it's 3 minus 1, which is f of 2. So the compiler then jumps to line 28 to enter the function, and on line 31 it checks to see if 2 is equal to 0 or equal to 1. The answer is no. So the compiler jumps to line 37, where f of 2 calls a recursive function call. 2 minus 2 is 0, so f of 0 is called. The compiler then goes back to line 28, enters the function, and on line 31 it checks the condition. Is f of 0 equal to 0? Well, the answer is yes, and so it returns that data. So f of 0 returns 0. The control then goes back to f of 2. F of 2 resumes on line 37, where the second Fibonacci number is called, with 2 minus 1, and that gives us f of 1. The compiler then enters the function on line 28, and on line 31 it checks, is 1 equal to 1? The answer is yes, and so 1 is returned. The control then goes back to f of 2, and it resumes on line 37. There's nothing left to do, so it adds data minus 2 plus data minus 1, and in this case 0 plus 1, so f of 2 becomes 1. The control then resumes back to f of 3, and f of 3 resumes on line 37, where there's nothing left to do, so it returns the addition of f of 1 plus f of 2, and in this case 1 plus 1 is 2, so f of 3 becomes 2. The control then goes back to f of 5, and f of 5 resumes on line 37, where it calls its second recursive function, and in this case 5 minus 1, and 5 minus 1 gives us f of 4. The compiler then jumps to line 28 and it enters the function, and on line 31 it checks, is 4 equal to 0 or equal to 1? The answer is no, so the compiler jumps to line 37. F of 4 then calls its first function, 4 minus 2, which gives us f of 2. Well, we know that f of 2 looks like this f of 2, but for tutorial purposes, we'll go ahead and keep going and expand it. So the compiler then goes to line 28, enters the function, and it checks, is 2 equal to 0 or equal to 1? The answer is no. It jumps to line 37, where f of 2 calls its first recursive call. 2 minus 2 is 0, so f of 0 is called. The compiler then jumps to line 28 and enters the function. Then it checks the condition on line 31, is 0 equals 0? The answer is yes, and so 0 is returned, so f of 0 is 0. The control then goes back to f of 2. F of 2 resumes on line 37, where it calls its second Fibonacci number, 2 minus 1, which gives us f of 1. And so the compiler goes back to line 28, enters the function, and on line 31 it checks, is 1 equal to 0 or 1 equal to 1? The answer is yes, so it returns f of 1, which is 1. The control then goes back to f of 2. F of 2 has nothing left after line 37, and so it adds the two results. 0 plus 1 is 1, and so f of 2 returns 1. The control then goes back to f of 4, And f of 4 resumes on line 37 where it calls its second Fibonacci function. 4 minus 1 is 3. Compiler jumps to line 28, enters the function. On line 31, it checks, is 3 equal to 0? No. Is 3 equal to 1? No. So it jumps to line 37 where f of 3 calls its first recursive call. 3 minus 1 is 2, so f of 1 is called. Compiler then jumps back to line 28, checks the condition on line 31. Does 1 equal 0 or 1 equal 1? The answer is yes, so 1 is returned. The control then goes back to f of 3, where f of 3 resumes on line 37 and it calls its second function of 3 minus 1, which gives us f of 2. Compiler then goes to line 28, enters the function, and it checks the condition on line 31. Does 2 equal 0? No. Does 2 equal 1? No. So it jumps to line 37. And on line 37, it calls the first recursive function, 2 minus 2, so it calls f of 0. Compiler then jumps to line 28, enters the function, and it checks the condition on line 31. Does 0 equal 0? The answer is yes. And so it returns that data, which is 0. The control then goes back to f of 2. F of 2 resumes on line 37 where it calls its second Fibonacci, 2 minus 1, which gives us f of 1. The compiler then jumps to line 28 and enters the function. And on line 31, it checks the condition. Does 1 equal 0 or 1 equal 1? The answer is yes. And so 1 is returned. The control then jumps back to f of 2. And f of 2, there's nothing left to do after line 37, and it returns 0 plus 1, which is 1. So f of 2 is 1. The control then goes back to f of 3. There's nothing left to do after line 37 on f of 3, so it returns 1 plus 1, which is 2. The control then goes back to f of 4, and again on line 37, there's nothing left after line 37, so it adds 1 plus 2, and f of 4 gives us 3. The control then goes back to f of 5, and f of 5 resumes on line 37 where there's nothing left to do other than to add 2 plus 3, and so f of 5 returns 5. And let me highlight all of the numbers that it returned. So 0 plus 1 returns 1, and 1 plus 1 returns 2. Okay, 0 plus 1 returns 1. And 1 plus 1 returns 2. 0 plus 1 returns 1. And 1 plus 2 returns 3. And 2 plus 3 returns 5. And once f of 5 function is completed, the control then goes back to main, and the output is 5. So I'll write the output up here, which should be 5. And let me compile it one more time. There it is, 5. And to our question earlier, what happens if we take out one of this base case? What if we remove data equals 1? Well, by the time we get to 1, it'll keep subtracting until this becomes a -1, then -2, a -3, and the stack frame keeps filling up, and eventually we'll run out of memory and have a stack overflow. And that's why it gave us an error on a couple of videos ago when we tried to print out. If you examine this tree, you can see that this is level 0 and this is level 1. So the first time we invoke the function, that's level 0. When we invoke F3 and F4, that's level 1. When we invoke F1, F2, F2, and F3, that's level 2. This would be level 3, and this would be level 4. And if you notice here, we have 1 invocations, 2 function calls or invocations, 4. This should be an 8, but because f of 1 is a base case, it didn't get there, and this should be a 16. And as you can tell, this is the same thing as approximately this. And so 2 to the 0, 2 to the 1, 2 to the second, 2 to the third. So 2 to the 0 is 1, 2 to the 1 is 2, 2 to the 2 is 4, and so on. And so in terms of time complexity, this is going to give us big O of 2 to the n. And in terms of space complexity, well, that's just the stacks generating on the stack frame. This is going to give us big O of n. And this sums up the tree trace for the Fibonacci sequence. Thank you for watching.